Bismillahirrahmanirrahim. This is Shahnaz Saeed from Ibn-e-Rushed Govt Girls Degree College, Mirpurkhas, lecturer chemistry. Students, this is my lecture number 4, that is from chapter 5, energetic of chemical reactions, and today's topic is the first law of thermodynamics. Students, in the first law of thermodynamics, first we discuss about the internal energy. Every system containing some quantity of matter has definite amount of energy. This energy is the sum of kinetic energies and the potential energies of the system. Thus, kinetic energy includes translational, vibrational, and rotational kinetic energies of molecules. The kinetic and potential energies of nuclei and electrons within the molecules also contribute to the energy of the system. The total of all the possible kinds of energies of the system is called its internal energy, that is denoted by capital E or capital U. The change in internal energy of the system is a state function. It is not possible to measure the absolute value of internal energy of a system, but it is often possible to measure the value of delta E for a change in the state of the system. There are two fundamental ways of transferring energy to or from a system. These are heat and work. Heat is not a property of a system. It is therefore not a state function. It is defined as the quantity of energy that flows across the boundary of a system during a change in its state due to difference in temperature between the system and the surroundings. Work is also a form of transfer of energy from one system to another. It is defined as the product of force and displacement is called work. SI unit of work is joule. There are different kinds of work. The type of work we most commonly encounter in chemistry is pressure volume work. For example, expansion can occur when a gas is evolved during a chemical reaction. In such cases, the work done W by a system is given by W equal to minus P delta V, where P is the external pressure, V is the change in volume. Work is not a state function.